This is the video lesson for 4.3. In this lesson, we're going to see how to factor quadratic relations where a, this value here in front of the x squared, is equal to 1. So what we're doing is we're going to go from the standard form to the factored form, and we're going to use a method called factoring. Now what I want you to get is that there's different types of factoring that can be done, and we're going to see those different types as we proceed throughout these lessons in this unit. So one type of factoring is called finding a common factor. Another type is just a simple trinomial. And in this simple trinomial, what we do is we find a product and a sum, and we'll see what that means in just a bit. There's a method called decomposition. And a method called difference of squares. Difference of squares. So if we take a look at this little chart over here, if we go from this expression over here to this one over here, this would be the case of expanding. And remember that if you want to factor, if you want to do factoring, that's the opposite of expanding. So going from this one to this one, that would be considered factoring. So the opposite of expanding. So our main key takeaway there was factoring is the opposite of expanding. If you were going from this form here, this factored form, to this standard form, what you're doing to go from this factored form to the standard form is you need to expand. And if you're going from this standard form to the factored form instead, so the other way around, you are factoring. You factor to go from standard to factored form. Now, what I want you to notice in these examples that we have here is that there's actually an interesting relationship. I'm going to label some numbers here. So remember in our factored form, this number over here is called s. This number over here is called t, and there are zeros. So we have x is equal to -2 and x is equal to -3 as our zeros, but s and t over here. And this number over here is called, we'll call this again b in our standard form. And this one here is c in our standard form. And I want you to notice something interesting. If you add s and t together, so 2 and 3 over here together, you actually get 5, which is b. 2 plus 3 gives you 5, which is b. And another thing I want you to notice is if you multiply s and t, so s multiplied by t, 2 times 3 is 6. 2 times 3 is 6. You get c. So we can use the knowledge of that relationship to help us with our factoring. And so we're going to see how to do that with some simple steps. So first I'm going to write out the steps, and then afterwards we're going to do an example of factoring together. So our first step is to find the greatest common factor. After that, we want to find two numbers that have product C and sum of B from above. After that, we want to write two sets of brackets with x inside each one. After that, we're going to put one number inside one bracket and another number inside the other bracket. And then lastly, just to make sure you did the factoring properly, you're going to expand to verify. So if these steps didn't make a lot of sense just by writing them out, they may not. We're going to do an example together to see where all these steps come into play. So these are some steps to factoring simple trinomials. We're going to be doing the product sum, and we're focusing on trinomials that have an a value that's equal to 1 in this lesson. So we're going to go and try a simple polynomial where we have x squared plus 6x plus 9, and we're going to follow the steps using the patterns that we just discussed. So let's label over here. We have b, this is our b, and this is our c in the standard form. And we're asked to factor. So what you need to do is, you need to find the number, or two numbers, so that when you add them up, they'll give you 6, and when you multiply them, they'll give you 9. So basically, when you multiply them, that's the product, they give you 9. When you add them up, that's the sum, S, they give you 6, because that's our B and our C here. So two numbers that would do that would be 3 and 3. 3 times 3 gives you 9, and 3 plus 3 gives you 6. So what we just did here is we found two numbers. When you add them up, they give you B. When you multiply them, they give you C. Now there's no greatest common factor in this situation, so we don't have to worry about step 1 over here, but we went to step 2 right away. So that's what we found here, product and sum. And now we're going to go and we're going to write our brackets. We're going to draw our brackets here, two sets of brackets. So this over here is going to be equal to, my first bracket will be over here with an x inside. My second bracket will be right next to it with an x inside as well. And the two numbers are going to be written inside those brackets. So the first number is 3, and the second number is 3 as well. So this is our factored form. X squared plus 6x plus 9, and its factored form is x plus 3 times x plus 3. Notice that there's nothing in between the brackets here. That means that they're being multiplied together. Since these brackets are identical, x plus 3 in each of them, you can actually write this in a condensed form, x plus 3 squared, because it's x plus 3 times itself. Just like that. It's kind of like saying if you had, and this is just an aside here, 9 times 9, instead of writing 9 times 9, I could simply write 9 squared. And then what you can do is you could use FOIL to verify. So you would multiply using your first, outer, inner, and last terms to see if you get back to the x squared plus 6x plus 9. So let's try this out again, but this time for question B. So we want a product. So let's label this here. We have B and C. We want a product of 21. we want a sum of b, which is negative 10. So two numbers that when you add them up, they give you negative 10, and when you multiply them, they give you 21. And so you might do some trial and error at first. You might say, okay, well, 7 times 3, that gives you 21. But if you add 7 and 3 together, it gives you positive 10, not negative 10. Okay? What about negative 7 times positive 3? That doesn't work out either, because that would give you negative 21. What about negative 7 times negative 3? So if I have negative 7, multiply it by negative 3, that would be 21. And if I do negative 7 plus negative 3, that would be negative 10. So I found my two numbers, negative 7, and negative 3. So I'm going to make my brackets. X, X. My first number was negative 7. My other number is negative 3. It doesn't really matter which order you put these two brackets in. They'll give you the same thing when you multiply them and you verify using FOIL. So just to illustrate that over here, we can do that. So if we're using FOIL to verify our work, we're going to do the first term, so that would be x squared. The outer terms, so x times negative 3 is negative 3x. The inner terms, negative 7 times x, negative 7x. And the last terms, negative 7 times negative 3 is plus 21. And so that would give us, when you clean it up, x squared minus 3 minus 7 is minus 10x plus 21. And so since doing FOIL led us back to the same answer, to the same standard form we had in the question, it means that we did the factoring correctly. So let's do example C. So again, we want a product this time that's negative 10. And we want a sum, so this is B over here, this is C, a product of C, which is negative 10, and a sum of negative 3. So we want two numbers that when you multiply them together, they give you negative 10, and when you add them together, they give you negative 3. So you can try 5 and negative 2. Let's see if that works out. So if I do 5 times negative 2, that gives me negative 10. And if I do 5 plus negative 2, that gives me 3. So that doesn't work out. That there's wrong, because we don't have negative 3, we got positive 3. So 5 times negative 2 did not work out, so we're doing some trial and error here. Let's flip it around. Let's do negative 2 times, let's do negative 5 times 2. So negative 5 times 2 gives us negative 10. Negative 5 plus 2 gives you negative 3. So that works out. So our two numbers are negative 5 and positive 2. So we have x in our brackets here. We have minus 5 over here. And we have positive 2 over here. And if you did FOIL to check your work, you would get x times x is x squared. X times 2 is plus 2x. Minus 5 times x is minus 5x. And then minus 5 times 2 over here is minus 10. And then we would get x squared plus 2 minus 5 is minus 3x minus 10. We get back to the same expanded form from above, the same standard form from above, so we did the factoring correctly.